See this? You're looking at the best full portrait of the Sun by far. Thankfully, our 4.5 billion-year-old parent star didn't use any makeup to fix its skin tone before this photo shoot. And now we can study its surface in great detail. This iconic image was taken in March 2022. NASA wanted to gain a better understanding of solar behavior and its impact on life on Earth, and the future of our space technologies, of course. To do so, they launched the Solar Dynamics Observatory Satellite, or SDO, mission in February 2010. This legendary photo shoot happened 12 years later, when SDO was halfway between the Earth and the Sun. Scientists had to assemble 25 individual images like a puzzle, so the final image contains 83 million pixels. Yeah, the resolution is about 10 times better than your fancy 4K TV screen. Look at this amazing cookie-like pattern. Typically, the bright surface of the Sun overshadows it when we observe the star from Earth. Thankfully, NASA explored the light beyond the visible range, which allowed them to discover some invisible details of the Sun's face. When you adjust your selfie with filters and effects, you can end up with completely different portraits, highlighting different spots of your face, even those you didn't know existed. The same principle works here. All these plasma balls are the same photo of the Sun, captured at different electromagnetic wavelengths. The revealed spots and patterns can help us understand events happening inside the Sun's skin a little better. At the speed of light is supposed to mean super quick. But this rose gold ray caressing your cheek at dawn has come a long way and is incredibly old in human terms. Photons generated by the Sun's core take between 10,000 to 170,000 years to travel through the star's atmosphere, and then around 8 minutes more to reach Earth. So let's explore what's taking them so long. Our tour begins with the upper layer of the Sun's atmosphere. Remember solar deities in movies and theater plays? They often wear luxurious crowns with golden rays. Well, the real Sun does wear a fancy corona too, which is the outer layer of its atmosphere. But of course, its size and glory are incomparable with those plastic costume crowns. And its shape is not so stable. Corona is a gas shell enveloping our parent star, so its size and form constantly fluctuate under the influence of the Sun's magnetic field. You can spot this crown with the naked eye from Earth during total solar eclipses. It looks like a beautiful, intense radiation around the solar disk, which itself is completely blocked by the Moon. The corona stretches 5 million miles above the Sun's surface, whereas our blue planet is only about 8,000 miles in diameter. So, one hypothetical ray of the corona equals a row of about 625,000 Earth-sized planets. And suddenly, all my problems begin to seem tiny. Now here's another fun fact. The Sun's corona kind of breaks the laws of known physics because it's hotter than it should be. Its temperature reaches 2 million degrees Fahrenheit, whereas the surface of the Sun is only about 9,000 degrees. Although the word "only" doesn't fit here, because it's still super warm in human terms. Usually temperature tends to fall as you move farther from a heat source, but it's not the case here. Space scientists are still scratching their heads trying to investigate this mystery. Thankfully, the recent photo shoot allows us to explore what's going on inside this massive hot stuff without risking losing our sight. Take these beautiful bright spots, for example. They depict solar flares happening under the corona layer. Solar flares are powerful explosions that happen when magnetic fields bump into each other. When it happens, they change shape and quickly reorganize. These fields arise from plasma, which is very turbulent itself, so these events are no surprise for the local weather. Now, who would have thought that the Sun has dark spots on its skin, just like people? These darker areas are known as coronal holes. Earthlings can experience their impact when they observe the beautiful aurora lights in the polar regions. Coronal holes look darker because plasma in these spots is cooler, less dense, and magnetically open. These conditions allow the solar winds to escape outward across the solar system rather than hang out at the Sun's surface. And when they bump into the Earth's magnetosphere, auroras emerge to fascinate our eyes. Thankfully, the local fields cool down the solar winds. Nobody wants their eyes to melt, right? Now, if we were looking for an analogy to the Sun's hairs, the best candidate would be solar prominences. These large, bright plasma loops arise from the Sun's surface and stretch for thousands of miles into space. Their lifespan varies from days to several months. It's one of the most common events in this region. Although the first detailed description of solar prominence dates to the 14th century, modern scientists are still researching how and why they're formed. Diving further inwards, we're facing the transition region. The thickness of this layer is about 62 miles, and the local weather is unthinkable. Temperatures can rise up to 900,000 degrees Fahrenheit. The transition layer sits between the corona and the last region of the Sun's atmosphere, called the chromosphere. Now, speaking of which, welcome to our next stop. The chromosphere region is famous for a scientific mystery called a spicule. Come on, say it with me. Spicule. That's fun. These spectacular grassy-like jets of plasma fire upwards from the surface of the Sun and reach speeds of approximately 224 miles per second, as if they're jumping on a trampoline from the surface of the Sun. Each spicule lasts for just a few minutes in outer space before falling back into the solar atmosphere. Astronauts were having a challenging time trying to explain how magnetically charged particles could manage to escape the massive gravity of the Sun while being so close to it. The possible answer emerged in 2017. A group of scientists discovered that neutral particles provided the magnetically charged particles with extra buoyancy to escape the solar gravity for a while, which is better than my cousin's explanation, which is happy thoughts and pixie dust. Yeah. Now let's go ahead and travel 1,000 miles inward toward the chromosphere to finally reach the solar surface, the photosphere. It's around 248 miles thick, but unlike planet Earth, the Sun's surface is not solid or stable at all. The temperatures here are insanely hot for any matter to exist. On the other hand, scientists often call plasma the fourth state of matter. And why not? It's made of ionized atoms and free electrons, so it kind of deserves to matter. So what's the matter? Maybe someday we'll happen to meet the local civilization of plasmoid people. But I think it's best that we skip their welcoming warm hugs. You know, hot, hot, hot. Anyway, the photosphere is our final stop, because humankind doesn't have the technology to explore the Sun any deeper. So if you want to learn more, you'll have to invent your own spacecraft. But time's a-wasting. You'll only have about 7 to 8 billion years. After that, our Sun will fade away, according to scientists' estimates. Actually, those same scientists will be going first. Now, you have a serious competitor, though. NASA's Parker Solar Probe is the current champion for the deepest dive into the Sun. The spacecraft managed to travel 4.5 million miles from the Sun's surface toward its core on September 27, 2023. And then, the Parker probe repeated its own record once again in December of the same year. So, why didn't it melt, I hear you asking? The probe has been designed to withstand insanely intense conditions and temperature fluctuations. It's equipped with a custom heat shield and an autonomous system protecting the mission from the massive solar lights. NASA has further ambitious plans. In December 2024, Parker will make its closest approach to the Sun. It will travel faster than any man-made object has ever traveled, at the speed of 435,000 miles per hour. The probe will be just 3.8 million miles away from the Sun's glowing hot surface. It's like landing on a star. Astronomers have already compared this epic upcoming milestone with the moon landing. I'm thinking, however, it might be safer if we, landed at night. Yeah, you're right, that's an old joke.
From where we stand, the Sun seems so calm and peaceful. But like humans, and basically the whole living world, the Sun has its own phases when it's more or less active. It's just that the consequences are way bigger and more chaotic when the Sun becomes hyperactive. Let's zoom in to see what's happening up there. So one of the ways we measure the activity of our star is by counting sunspots on its surface. Sunspots are dark patches that form when the Sun's magnetic field gets all tangled up. It's simple. The more sunspots, the more active our Sun is. And it seems the Sun has been partying like crazy recently. The number of sunspots scientists have seen is the highest for nearly 21 years. In June, 163 sunspots appeared on the Sun's surface. The last time we had so many dark patches across the Sun was in September 2002, when there were 187 of them. Uh-oh. It seems this chaotic party is getting closer to its peak. And that's something we call solar maximum. How does all this even happen? The Sun's magnetic field is strong and organized at some point. But as we said, Sometimes comes the time when it kinda ends up tangled, sort of like a ball of rubber bands that are wound together very tightly. This also means plasma is rising from the surface, forming loops, and causing a mess in the shape of solar flares and something we call coronal mass ejections, CME. That's when plasma in the sun's upper atmosphere, called the corona, goes crazy and bursts really strong. Then at some point, this ball snaps and completely flips and turns the South Pole into the North Pole and vice versa. All this happens every 11 years or so. So when the sun comes into this phase when it becomes very active, it shoots out hot blobs of plasma, gets big dark spots as large as planets, and releases powerful eruptions of energy and radiation. Something fascinating happens when the sun becomes more active. A thing called plasma waterfall or polar crown prominence, PCP. It's like a mini eruption that starts on the sun, and it seems like it tries to get away, but then the sun's magnetic field pulls it back before it can escape into space. And this plasma waterfall's really spectacular. It goes up to 62,000 miles above the surface. It's like you stack 8 Earths on top of each other. Then there's something called a polar vortex. It's like a gigantic halo of plasma that rotates around the sun's north pole really fast. This vortex happens when a large tentacle of plasma snaps apart and falls back toward the surface, similar to how a plasma waterfall forms. Scientists don't know why this plasma stays above the sun's surface for so long. And one of the cool examples of CMEs was a giant one in the shape of a butterfly in March this year. It got such an unusual shape because it exploded on the side of the sun we couldn't see, so it was impossible to fully measure how strong it was. Fortunately, that one didn't explode in our direction, but it might have hit Mercury a little bit. And it's possible it knocked off some dust and gas since Mercury has a weak magnetic field. All this sounds cool in theory, but it's not such good news for us. Because of all this, we might experience more intense solar storms that can, again, lead to geomagnetic storms on Earth. And these don't just sound alarming, they indeed are. They create chaos and disrupt the magnetic field of our planet. Geomagnetic storms can create beautiful northern lights, true. But we'd all rather enjoy such beauties as the aurora borealis in regular conditions, or just watch a good old sunset above the ocean. It's not that every solar storm will necessarily hit Earth, even if there are more of them. To reach our planet, they must be pointed in the right direction at the right moment. But if that happens, the storm can ionize the upper atmosphere, and bye-bye our communications. It can cause temporary blackouts for systems such as GPS and radio. It isn't necessarily a big problem on its own, but it can be very dangerous if it happens at the wrong time, like during a tsunami or an earthquake. The storms can also damage electrical infrastructure, like rail lines and power grids. If you're on a plane at that time, you might be exposed to higher levels of radiation. It's still not clear how dangerous that will be for you, but it can be a serious problem for astronauts in space. When solar storms mess with the magnetic field, this can affect the migrations of some animals, such as sea turtles, whales, and birds. Since things in the animal kingdom mostly work in the natural order, who knows how these animals go through or even survive such changes? And when the sun is at a maximum of its activity, satellites in space are in trouble too. We have more satellites in space than ever before. And when the upper atmosphere becomes denser because of all these changes, this can push satellites in different directions. They might crash into one another, or some can even fall back to Earth, which again is only cool in movies with superheroes who can relatively easily deal with this stuff. Hopefully, we'll avoid a massive solar storm like the Carrington event. The story was similar. In August 1859, astronomers across the globe watched how the number of sunspots was getting bigger and bigger. A man named Richard Carrington was among them. At the beginning of September, he was sketching the sunspots when, out of a sudden, he was blinded by a flash of light. It lasted around 5 minutes, but it was spectacular. He later described it as a white light flare. It was a very strong coronal mass ejection, CME, and in only 17.6 hours, this storm crossed the long way between the sun and our home planet, 90 million miles, and unleashed its force on us, even though this usually takes days. And when this storm started, telegraph machines across the world sparked. Operators got electric shocks, and paper even caught fire. People were really scared and confused because they had never seen such bright skies before. Some even thought it was the end of the world. The next day, telegraph workers still couldn't work properly because Earth's atmosphere was still charged. They even managed to send messages using the auroral current instead of regular electricity. But it brought something incredible, 2 stunning auroras in the sky. People in Hawaii and Cuba could see beautiful northern lights, while those as far north as Chile could see the southern lights. It's all slowly but steadily escalating. Take solar flares, for example. These are powerful bursts of energy from the sun. In 2022, there were 5 times more of these flares compared to the previous year. Plus, the strongest ones, X-class flares, have been getting stronger and more common than before, too. And this might be way more extreme than anyone thought. Plus, it's likely to start a little bit earlier than we predicted. Scientists first thought the peak would happen in 2025, but it seems it could even occur by the end of 2023. We can't completely protect ourselves if a solar storm hits us directly, but we can still do some things like ground planes, adjust the paths of satellites in space, and try to make sure vulnerable infrastructure stays safe. To do all this, we need better solar weather forecasts to help us get ready for the worst. All this might sound very bad at first, but don't worry, solar flares won't destroy our planet. They do send charged solar material toward us at pretty high speeds, but it's not like we're completely doomed if these things hit us. Our planet won't leave us unprotected. We still have the atmosphere and magnetic field that keep us relatively safe. Our thick atmosphere is like a shield that blocks radiation that might harm us. So these solar flares can mostly affect technology, but they won't destroy Earth. I guess we have our own superheroes after all.
What if the sun went boom? Well, you can guess it would be super bad news for us. This was sure a short video, huh? Nah, wait, I have more. If the sun blew up, chaos would ensue in our solar system. But scientists tell us that it will certainly happen one day. But why? How exactly would events unfold? And is it possible for us to somehow survive this event? Hey, let's delve into it. First of all, get ready for a journey to the sun's core. The sun's heart is packed with hydrogen atoms, having an out-of-this-world dance party. These atoms are so excited that they smash into each other with all their might. And when they collide, something magical happens. It's called nuclear fusion. And in this fusion fiesta, the hydrogen atoms combine to form helium atoms, a chemistry experiment on a grand scale. During this nuclear fusion, a teeny bit of mass from the hydrogen atoms is transformed into a massive amount of energy. It's Einstein's famous equation E equals mc squared coming into play. Energy is unleashed in the form of light and heat, radiating outwards to brighten up the entire solar system. And once all these processes get going, a bunch of energized particles called photons join the fun. These photons are like tiny packets of light, bouncing and zipping around in all directions. They play a crucial role in carrying the sun's energy through space, illuminating our world and warming our cozy planet. But to keep all this going, so that atoms don't escape and create complete chaos, the sun's core needs to be under tremendous pressure. This pressure comes from the immense weight of the sun's outer layers pressing down on the core. The outer layers are squeezing the inner core. But the inner layers don't give up. The energy created from fusion and the bustling photon party tries really hard to escape the sun's core. But the core is so dense, like me, and the pressure is so big that the energy takes its sweet time to make its way out. It bounces around, gets absorbed, and re-emitted by other particles. Eventually, after a long time, it reaches the sun's surface and zooms off into space, reaching us as sunlight. So now you know how the sun works. Now, what happens once it reaches the end of its life? Well, here's the twist. Our sun has a limited supply of hydrogen fuel. In about 5 billion years, it'll run out of its fuel. After that, the star will undergo some big changes. Now, pay attention, because there's a pretty good chance we're all going to miss this. First, the sun will puff up and become a red giant, exploding like a balloon. It will grow so big that it will swallow up the inner planets, including our beloved Earth. Talk about a sun taking up all the space. So we won't even see the end of our sun unless we move somewhere further away. After the red giant phase, the sun will shrink a bit. Its outer layers will fade away into space, leaving behind a beautiful planetary nebula. It'll be revealing its glowing core. Ooh! The core, now filled with helium,
will start sounding weird.
and will start fusing heavier elements like oxygen and carbon. These reactions won't be as energetic, like a party with less dancing and more chill vibes. Eventually, even the helium will be used up, and the Sun will become a compact white dwarf, a stellar retiree enjoying its retirement home. Scientists estimate that the Sun has about 7 to 8 billion years left before it dims its lights. Don't worry though, by that time, humanity might have traveled to far-off galaxies, or maybe even evolved into amazing space beings. So our Sun won't go out with a bang like fireworks. It's not big enough to become a supernova or a black hole. Those stellar superstars need way more mass than our Sun to pull off those cosmic tricks. But what if it blew up very suddenly, just like an abrupt event without any reason? Well, let's see. Imagine this. The Sun goes boom, and Earth is in for a wild ride. The event unleashes an insane amount of energy, sending a shockwave racing through space at the speed of light. It takes about 8 minutes for this shockwave to reach Earth. Why? Well, the Sun is a whopping 93 million miles away from us on average. So it takes a little over 8 minutes and 20 seconds for the Sun's light to travel all that distance and reach us. But let's talk about the event itself. It would be a great sight to witness, but sadly, it would also be the end. Roll credits. The crazy amounts of unleashed energy would cause the Sun to expand rapidly, again swallowing up the inner planets, including our Earth. And that's not all. Brace yourself for a massive burst of radiation. The Sun would unleash a torrent of supercharged particles. We're talking about X-rays and gamma rays, the kind that can seriously mess things up. When these high-energy particles hit the atmosphere, they go wild, causing all sorts of chaos. They ionize the atmosphere, creating a ginormous electromagnetic pulse. This pulse is like a shockwave for electronic devices. It fries them, zaps them, and leaves them useless. So if your gadgets aren't protected, they're in for a rough time. Speaking of rough times, after that, it's instant vaporization for our planet. But the Sun's grand finale just doesn't mess with Earth. It wreaks havoc on the entire solar system. That massive burst of energy would be crashing into everything in its path. Planets and other objects get knocked off of their cozy orbits, causing chaos and unpredictability. The asteroid belt between Mars and Jupiter, kapow! It's gone, obliterated, or scattered to the cosmic winds. And even planets that will survive this event will probably go off their orbits to wander somewhere. And let's not forget about the outer planets, like Jupiter and Saturn. These giants generate their own internal heat, which keeps them cozy and attracts lots of moons. But the Sun's boom would steal their warmth, turning them into incredibly cold places. And now that we've discussed how catastrophic all this would be for everything in our solar system, let's ask the logical question: can humanity make it? The short answer is nope, we wouldn't make it. Everything would be wiped out, except maybe some sneaky bacteria hiding in the shadows. But in a crazy scenario where the Sun gave us a heads up about its plans, we might have a fighting chance. If we knew in advance and had time to prepare, we could get our survival gears turning. So what could we do? Since Earth itself won't survive the Sun's tantrum, we'd have to move somewhere. Remember how we mentioned that not all planets would be completely destroyed? Well, sadly, the ones closest to the Sun, Mercury, Venus, and Earth, would disappear. So the easiest option would be to move to some other solar system with its own Earth-like planet. But what if the Earth somehow managed to survive this catastrophe? Let's not think about how it happened and just discuss the consequences. Well, our climate would go crazy. During the first moments of the Sun's kaboom, the radiation and particles would crank up the temperature big time, like a never-ending heat wave. We're talking major greenhouse effect. The oceans would evaporate, creating thick, fluffy clouds that trap heat and refuse to let it escape into space. And after that, without the Sun's warm embrace, the Earth would quickly become an icy freezer. So we'd have to think outside the box. One idea would be to take shelter deep underground, where we won't be that much affected by radiation and sudden temperature changes. As you dig deeper, the temperature rises. So, with the right tools and resources, humanity could hunker down in fortified bunkers, surviving for a couple of years without the sun's rays. Why just a couple of years? Well, remember how we said the sun is a gravity center of our solar system? Without it, Earth would be adrift in search of a new center of gravity. Imagine our planet, our trusty satellite, the Moon, and all the other planets slowly floating away into space. Luckily, our trusty sun is hanging in there, keeping us warm and shining for many more cosmic adventures to come. So, we're safe for a few billion years. But it's always fun to imagine impossible scenarios. So stay tuned for more what-ifs.
What happens when a star runs out of its fuel? First of all, paradoxically, it grows to 1,000,000 times its original size. You see, when the core of a star runs out of hydrogen, it starts contracting under the weight of its own gravity. But some hydrogen fusion continues in the upper layers. While the core contracts, it heats up. This causes the upper layers of the star to heat up too and expand. The radius of the star increases. As the star grows, it engulfs any matter, even its own planets, in its wake. Astronomers have watched stars right before or straight after swallowing entire planets, but until recently, they have never seen the process itself. Scientists from different universities have reported that for the first time in history, they've observed a star swallowing a planet. And this tragic event happened not somewhere in a faraway galaxy, but in our own Milky Way, some 12,000 light-years away from us. Astronomers spotted an outburst from a star, which is around 0.8 to 1.5 times the mass of our Sun, near the eagle-like constellation Aquila. It became over 100 times brighter than usual in a mere 10 days, and after that, it quickly faded away. Even more interesting, this white-hot flash was followed by a longer-lasting signal that was also colder than the first flash. And this combination, my friend, could only mean one thing. The star engulfed a nearby planet. What planet was it? Astronomers believe it could be a boiling hot world from 1 to 10 times the mass of Jupiter. Such planets are also called hot Jupiters. They're giant exoplanets similar to the Jupiter we have in our solar system that need less than 10 days to orbit their stars. The planet we're talking about had been gradually spiraling toward the star until it was pulled into its atmosphere and, eventually, into the core of the perishing star. This galactic feast happened between 10,000 and 15,000 years ago when the star was about 10 billion years old. And given its respectable age, the swallow itself happened lightning fast, in one fell swoop. This is very different from other hot Jupiters, which were quite delicately nibbled by their stars. Astronomers aren't sure if there are any other planets orbiting this star, perhaps at a safer distance. But even if there are, thousands of years will probably pass before they become the star's main course or dessert. In any case, now that astronomers know what they should search for, they're going to be on the lookout for more cosmic gulps. Because one day, our planet, as well as part of our solar system, will suffer the same fate. Everything around us will be gone in a flash. But you may relax and breathe out. It won't happen for another 5 billion years. That's when the sun is supposed to burn out and expand so much that it will swallow the inner planets of the solar system, Mercury, Venus, Earth, and Mars. If people manage to colonize some other world by that time, which should be at least 10,000 light-years away from Earth, they would be able to observe this catastrophe. The sun would suddenly become much, much brighter, and it would eject some material into space. It would swallow several planets, including Earth, before nonchalantly setting back to what it was. But stars are not the only things in the universe that swallow other space objects. There's another kind of cosmic monsters that munch on everything, even light. Have you guessed? Right. I'm talking about ruthless black holes. But what is more interesting, they not only devour stuff, but also seem to spit it out. Not so long ago, scientists found out that the supermassive black hole at the center of our home Milky Way galaxy seems to be leaking. Why is it a game changer? Because it might mean that this black hole, called Sagittarius A*, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active, and this leakage may be the whole hiccuping while swallowing clouds of gas. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often happens around active black holes, surrounded by the material, pulled toward them by their immense gravitational pull. Some of this material gets into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches mini jets of matter. Fermi bubbles might be the result of the belches that happened around 2 to 4 million years ago. But recently, scientists have discovered another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light-years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now I'll tell you something even creepier. There seem to be black holes that might be eating each other. Well, kind of. They're actually trying to share their meal at the moment, but who knows what will happen in the near future. But let me go into detail. Astronomers have spotted 2 supermassive black holes, feasting on the cosmic material of 2 merging galaxies in distant space. These giants have been located with the help of the Atacama Large Millimeter Submillimeter Array of Telescopes, also known as ALMA. These telescopes are in northern Chile's Atacama Desert. Scientists originally used them to watch 2 merging galaxies located about 500 million light-years away from Earth. Astronomers have also noticed that 2 gigantic black holes were growing alongside each other not far from the center of the coalescing galaxy, UGC 4211. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, about 125 million times the mass of our star. Even though they aren't visible directly, the black holes are surrounded by bright clusters of warm, glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Times will pass, and these black holes will start circling each other, and eventually they will collide, creating one, probably even bigger black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are kinda unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. Interestingly, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around black holes. Imagine how surprised astronomers were when instead of one black hole, they saw 2 of them, munching on the dust and gas stirred up by the massive space merger. The most important thing about this discovery is that it may mean that such black hole binaries are likely to be much more common than we previously thought. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves that occur when black holes collide. Such waves are also known as ripples in spacetime. If we talk about the recently discovered pair of black holes, it might still take them several 100 million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes that are about to collide exist in the universe.
Consider the rogue planet, the cosmic wanderer that nobody wants to take home. Basically, a rogue planet is a planet that has been ejected from its own star system and is now floating aimlessly through space like a cosmic loner. These planets aren't just a theory. Scientists have actually detected some in our galaxy. In fact, estimates suggest that there may be lots of these cosmic nomads floating around the Milky Way. And they aren't just small rocky worlds like Earth. Some of them are actually massive gas giants, many times larger than Jupiter. These behemoths could potentially have their own moons, and even their own mini-systems orbiting around them. For example, one of the most famous rogue planets we know of has a complicated name. Here, you read it for yourself. It's located about 80 light-years away from Earth, and it was discovered in 2013. This rogue planet is estimated to be around 6 times the mass of Jupiter, and is believed to be around 12 million years old. And yes, just because these cosmic loners don't have a star, it doesn't mean they're super cold. They can still generate heat and light from their own internal processes. Some may even have magnetic fields and auroras, just like Earth. In other words, rogue planets could potentially be habitable if they have the right conditions. So, what would life on such a planet look like? And could we potentially live in such a world? Well, living on a rogue planet can be a lonely existence. They have no warm sun to bask in, no cozy atmosphere to cuddle up in, and no cosmic neighbors to have barbecue with. That's why we'd have to get creative. Let's start with the most obvious problem. We'd have a hard time without light and heat. So, how do we fix this? Well, we'd probably have to invest in some really fancy space heaters and wear fashionable super-warm spacesuits. Or we could invent a whole new way to generate electricity without relying on solar power. For example, how about using geothermal energy? Now that's hot stuff. Each planet has an internal source of heat. Without it, they would all be nothing more than cold, lifeless rocks floating through space. This internal heat can be harnessed and used to power everything, from homes to factories to spaceships. It's like having a hot tub big enough to power an entire city. And that city, most likely, will be located underground, closer to the heat source. And as for light, well, we'd probably have to build some really bright flashlights. Or maybe even learn to genetically engineer some bioluminescent organisms to light up our homes. Just imagine, space is overgrown with neon mushrooms and plants. By the way, speaking of plants, plant life would be pretty hard to come by without a star. So, what would we eat? Well, we could use the same geothermal vents that we talked about, or some chemical reactions to sustain ourselves. And hey, maybe we'd develop a taste for sulfur-rich foods, or we'd start fermenting our own drinks from the bubbling volcanic mud. Yum! But besides food, we'd have a more important problem. Living on a rogue planet would be breathtaking, literally. We'd have no air. You see, not all rogue planets have good, stable atmospheres. It all depends on their size, composition, and other things. But even if our new home does have an atmosphere, it may be incredibly thin and unstable. We'd have no pretty blue skies or dramatic sunsets to admire. Instead, we'd be staring out into the infinite void of space, where the stars would be brighter than ever before. And forget about weather patterns. Without an atmosphere to create them, we'd have no rain, no snow, and no thunderstorms. And that's just some minor problems. What's worse, the temperature on the planet would be wildly fluctuating, swinging from unbearable heat to unbearable cold. It would be like living in an oven that's always being turned on and off. And finally, we'd be exposed to all kinds of space debris and cosmic radiation. So, if you don't want to get crispy, you might want to invest in some serious SPF. So, how do we fix it? Well, we'd have to find a way to generate our own oxygen and probably create something like a space-age biosphere. For example, we could grow some plants that could produce oxygen, or we'd learn to filter the air like a high-tech air purifier. Finally, we have the last most important problem, finding water. And here's where the underwater oceans come to our aid. Now we're really diving deep into the possibilities. Nyuk, nyuk. But seriously, scientists suggest that some of these planets may indeed have underwater oceans. It would be like living on a giant water balloon that's been buried underground, with the ground beneath your feet made of ice and rock. In other words, we could just tap into these underground oceans. They could provide us with a source of water for drinking, farming, and manufacturing. Maybe even with some other resources and materials we've never seen before. And by the way, who knows what kind of strange creatures might be lurking in those underground seas? But don't worry. Even if we don't have any underground oasis, there are also other options. We could get some water from comets, ice mining, and even from the atmosphere, the one we just created before. Finally, we need to find and mine some resources to build our homes and other stuff. And a rogue planet might not have the same kinds of resources as a planet that orbits a star. It's like trying to find some treasures in a desert, not exactly a sure thing. we may have to rely on resources from nearby asteroids and things like that. And if we want to extract resources from the planet itself, we might need to drill down through miles of ice and rock. But hey, if you're up for the challenge, there'll always be a chance you'll strike it rich on a rogue planet. And who knows, maybe you'll discover some new resources that are even more valuable than gold or diamonds. Great! Looks like we've solved the most important problems. Now, there may be other small difficulties. For example, we'd also have to deal with some seriously long days and nights, depending on how fast our planet was rotating. And we wouldn't have a normal, regular day-night cycle. The rotation of our planet could be wildly unpredictable. Maybe we'd have weeks-long nights, followed by weeks-long days, which could really mess with our sleep schedules. We might have to develop some really strong coffee to keep us going through those long, dark nights. But, hypothetically, we can adapt to all these things and overcome all the challenges. And now, finally, welcome to the Rogue Planet, where the sun never rises, but the adventures never end. Thanks to our advanced technology, we've managed to create a comfortable and habitable environment in this once barren world. The sky above us is now a beautiful shade of blue, filled with fluffy white clouds and the occasional flock of flying creatures. Don't ask. As we venture out from our underground habitats, we're greeted by a world that's full of surprises. Strange plants and animals have adapted to the unique conditions of this planet, some with bioluminescent features that glow in the dark. And be careful if you want to go swimming in the underground ocean. They might be home to some bizarre creatures who want to feast on… well, we'll come back to that. Maybe. As you can see, we've created sprawling cities and thriving communities, powered by the planet's geothermal energy. We also created a bunch of artificial light sources that keep things bright throughout the dark, chilly nights. Of course, we still have some problems with navigation and timekeeping, but things aren't as dull as they used to be, are they? Overall, living on a rogue planet would definitely have its challenges, but it could also be a pretty exciting way to experience the universe. And who knows? Maybe someday we'll find such a planet and actually turn it into a bustling intergalactic metropolis someday. But until then, let's enjoy and tidy up our dear Earth. Move over, Star Wars! Astronomers have discovered an exotic star system that puts you to shame. Did you know our solar system is a bit of a loner in the galaxy? Most stars actually have companions, and some even have multiple. For example, binary star systems are very common, consisting of two stars orbiting around a common center of mass. Usually, you can't see them with a naked eye. To an observer on Earth, they'll most likely mold together and appear to be one. For example, Alpha Centauri A and Alpha Centauri B together form a binary system. They're some of the brightest stars in their constellation and the third brightest in the night sky in general, outshined only by Sirius and Canopus. But if you look at them, they'll appear to be a single star. Although it's not always like this. There are also so-called double stars. They're located so close that they may seem like a binary system, and they can either be one or not. You can even do a little eye test. In the Big Dipper constellation, try to look for Mizar and Alcor. They're kind of hard to spot, but they're right there on the arm of the Big Dipper. Now, if you're able to see them not as one, but two, then you have good eyesight. And hey, why settle for just two stars when you can have more? Triple systems are also quite common, with three stars orbiting around each other in a delicate cosmic dance. These systems can be full of surprises because the orbits are so difficult to predict. But all this pales in comparison with the recent discovery. A few years ago, a team of researchers discovered an actual five-star solar system. It's located 250 light-years away in the Ursa Major constellation and was discovered by the Super WASP project. All of the stars there were formed from the same disk of dust and gas, and now they're connected in one complex gravitational dance. Now, this doesn't mean they're all incredibly close to each other. They don't do some kind of a square dance, you know. In fact, they're separated by more than the distance of Pluto's orbit around the Sun. Usually, such large systems consist of smaller ones. For example, in this case, there are two stars that are super far away. Two stars that are so close that one is practically stealing the other's hydrogen, you bad boy, and one tag-along lone companion. But they all orbit around a common center of gravity. With all these interactions, it's a wonder they don't collide and create one big bright mess in the sky. But it's not surprising that each such system is more complex and rarer than the previous one. And this all raises the question, what kind of unique environments could exist in such systems? What would our life look like if we lived there? Well, let's see. Picture this. You're on a planet orbiting one of the stars in a quintuple system. It's a sunny day, and you're ready to hit the beach. As you step out of your space house, you look up at the sky and see not one, not two, but 5 suns shining bright like diamonds. 2 of them are super close together, almost as if they were one. Then you see the other pair, a bit further apart, each with their own glow. And finally, the loner star in the corner, just doing its own thing. It's overwhelming, to say the least. Now, you might be wondering, but what would the day-night cycle and changing of seasons look like on such a planet? Well, here things might get a little complicated. Depending on the orbits of the stars, the planet could experience pretty random daylight and darkness hours. They can even be constant or last for very long periods of time. All depends on the location of the planet. If we lived in a binary star system, things would be easier. There would be 2 distinct periods of day and night as the planet orbits around the 2 stars. But with 5 stars, their brightness and position would be constantly changing, so the day-night cycle could get extremely chaotic. Hey, I need my sleep here. On the other hand, this would make for some pretty spectacular views. We could experience several different sunrises and sunsets, each of different brightness and color per day. The changing of seasons doesn't get easier. You know how on Earth we have 4 seasons caused by the tilt of our planet's axis in relation to the Sun? Well, in a 5-star system, the locations of the stars could drive our planet insane. It's like having multiple chefs in the kitchen, all trying to cook different dishes at the same time. For example, if we're closer to star A, we experience more summer-like conditions. If we're closer to star B, things will be more chilly and wintry. And if we're located somewhere in the middle, we'll experience both summer and winter at the same time. It's like trying to juggle multiple balls at once. And this is a super simplified explanation. There are also things like the planet's orbital path, the tilt of its axis, the gravitational pull, yada yada. In short, the weather forecast will now become 10 times more unreliable. I'd hate to be the weather person on TV. That's a no-win scenario. And if that's not enough, then how about a roller coaster of radiation? The nasty solar winds and heat from multiple stars could make the conditions on our planet super harsh, rendering it uninhabitable. For example, if you're unlucky enough to live too close to the binary pair of stars, you'll feel like you're constantly stuck in a microwave. But hey, at least you wouldn't have to go to the tanning salon. And if you're too far away from the stars, it would be like living in an eternal winter wonderland. And if you're somewhere in the middle, well, imagine living in a place where you can get sunburn and frostbite on the same day. And this is just the beginning. You see, with 5 stars in the mix, there's a whole lot of gravity to go around. That's like being in a group hug with some really strong and clingy friends. The gravitational forces from the stars could tug and pull at the planet, creating tides so strong they could wash away entire cities. And don't even get me started on the earthquakes. With all that gravity, the ground beneath our feet would feel like it's constantly shaking, rattling, and rolling. On the bright side, though, at least we'd always have an excuse for being late to work. Sorry boss, I got caught in a gravity wave and ended up on the other side of the planet. You're not buying that, are you? As you can see, we'd have to try hard to adapt to such a system. All this, obviously, would create some challenges for agriculture. With multiple stars in the sky, plants would have to adapt to receiving light from different angles and intensities throughout the day. Farmers might need to create something to protect crops from excess heat and radiation. On the other hand, having multiple sources of energy from the stars is pretty awesome. Imagine fields of solar panels soaking up the rays from all 5 stars. But hey, Maybe we would have been lucky and ended up on a planet where gravity and temperature changes wouldn't have bothered us so much. In that case, living in such a unique and inspiring environment doesn't sound too bad. It would have a great impact on our culture, arts, technology, and so on. With such a unique view of the cosmos, people would have a whole new canvas to work with. And just imagine, this isn't even the most complex of the systems we've discovered. For example, have you heard of AR Cassiopeia? It's a septuple star system, meaning it has 7 stars orbiting around each other. Now you might be thinking, wow, that must be a real chaos. And you're not wrong. Imagine trying to navigate a spaceship through all those gravitational fields. It's like playing a game of cosmic pinball. But all this serves as a reminder of the incredible diversity of the universe. Scientists continue to study and learn more about these rare and fascinating systems. And who knows what other mind-boggling star systems are out there, waiting to be discovered. Systems of 10, 15 stars. Nearly as many stars as there are in Hollywood. Get it? Stars? Hollywood? Okay, I agree, it's lame. Let's face it, as stars go, our sun is actually, well, pretty boring. Come on, there's nothing unusual about it. There are millions of similar yellow dwarfs in the universe. And yet, we love it. After all, it's the only star we have, and it gives us life. However, it wasn't always like that. Once upon a time, the sun had a twin, possibly an evil one. What happened to it? Well, let's find out. Now this here is a giant molecular cloud. They're also sometimes called dark nebula. Here, there are many interstellar clumps full of gas, dust, and piles of stars. These clouds have no clear boundaries and often take weird, crazy forms. You can even see some of them with the naked eye. Look at the clear sky at night. They look like dark spots all across the bright Milky Way. And this is exactly where our sun was born about 4.5 billion years ago. The sun originated from one of these molecular clouds. Billions of years ago, waves of energy were passing by here. They collected all this material and compressed these clumps into dense nuclei. That's when a protostar was born. This young protostar was a ball of lukewarm hydrogen and helium. And then, millions of years later, the temperature and pressure inside the balls increased. As a result, a star was born, the sun. But not everything in this molecular cloud has turned into the sun. The remaining materials began to revolve around the new star. And as you might have guessed, they gradually turned into planets, including our Earth. This is how our solar system was created. But it's quite possible that this is not the whole story, and that at the same time, along with our star, another one was born. The lost twin of the sun, made from the same materials under the same conditions. But why do we think that it exists? Well, recently, scientists have launched some statistical models to find out more about the birth of stars. And these models have shown that many stars appear not individually, but in clusters, or at least with one sibling. After more research, scientists confirmed that, yep, most stars formed inside molecular clouds are born with a companion. Sometimes these companions stay together. For example, a small star will revolve around a large one. They can even form double, triple, and other star systems. And sometimes their paths may diverge forever. This probably happened to our sun as well. It could have had a sibling too. Perhaps not even one, but a whole cluster of little brothers and sisters. And one bigger twin with a similar mass and other characteristics. But if that's the case, then where are you, our lost twin? Well, we have one hypothesis, and according to it, this twin may not be as good as it seems. In the 1980s, scientists began to notice a certain pattern in the Earth's history. Approximately every 27 million years, give or take, large-scale extinctions occurred on our planet. Pretty strange, right? Every 27 million years in the history of Earth, some kind of catastrophe occurred that changed its biosphere forever, as if something, as scheduled, cyclically, caused them. Then an astronomer, Richard Muller, suggested that there may be something that caused the events, a certain celestial body. According to him, it could be a dwarf star that we can't see because of how dim it is. It could be located about 1.5 light years away from us. This star rotates around the Sun in a huge orbit, and it approximately takes a whopping 27 million years for it to finish its orbit. And when it gets closest to the Sun, it starts to cause complete chaos. While approaching us, this troublemaker changes the trajectories of comets in the Oort cloud or the Kuiper belt. As a result, all these comets start to rush straight toward us. Then they crash into the Earth and cause mass extinctions, just like it was with dinosaurs. This hypothetical star was named Nemesis. It's the name of the ancient Greek deity of retribution. What is it taking revenge on us for? No idea. Perhaps it didn't like the fact that once upon a time, the Sun took away almost all the dust and gas from a molecular cloud. The Sun became a fairly large star, but the twin remained dark and small. Moreover, in the end, it was forced to fly away in the middle of nowhere. Anyone would be annoyed by something like this. Scientists have put forward various hypotheses about what the mysterious nemesis is. Perhaps it's a brown or red dwarf, the remnants of a star that has completely depleted its fuel. Or maybe it's not a star at all, but a rogue planet more gigantic than Jupiter. Well, whatever it is, its existence isn't particularly pleasant for us. However, all our attempts to find the culprit unfortunately failed. At the moment, we still haven't found any signs of Nemesis. Recent studies have called into question the theory of regular mass extinctions. If you look more into fossil records, you'll notice that these catastrophes occurred rather randomly, rather than on a clear schedule. Now scientists doubt if Nemesis may actually exist. They also say that any star moving in a similar orbit would be very unstable, and it's very unlikely that it could have survived for that long. But despite the lack of clear evidence, Nemesis had become quite famous online. Many articles and news still mention it in different contexts. They like to write off any dramatic events taking place in the world, like asteroid falls, tsunamis, and so on this mysterious star. So now, all this may seem like a typical urban legend, but let's not forget about something. Remain lost, and our sun will remain forever lonely. Ah, what a sad story. But cheer up, for us it's probably the best. If we had two suns, perhaps the solar system would never have become what it is now. Our planet might not exist at all, and that means that there might be no life. So we probably should be grateful for the sun's sacrifice. On the other hand, Our sunsets would look like the ones they have on Tatooine. Cool.
The dark days are mysterious natural phenomena that have occurred only a few times in the history of humankind. We can write them off as eclipses or just some weather events, but in reality, they're very creepy and we have no idea why they happen. So, what are these dark days anyway? What's so strange about them? Let's try to find out. The sun is off. What are we gonna do? That's what the residents of Yamal, Siberia asked meteorologists on September 18, 1938. In the morning, instead of going to work, they all gathered at the weather station. They were waiting for answers. All because on that day, they observed something inexplicable, an eclipse which they later nicknamed the Black Day. And neither astronomers nor meteorologists can explain what happened back then. Here's how one of them described this event. At 8:30 a.m., we noted a decrease in light. At the same time, the color of the clouds began to acquire a yellowish-brown, sometimes red-brown hue. By 9 a.m., the lighting had changed dramatically. It was as if you were looking at the world through a dark light filter. The brown tones of the clouds intensified. By 10:30 a.m., the sky and earth didn't differ from each other in lighting and color. Everything seemed homogeneous, black, absolutely devoid of light. Pretty creepy, right? And that's not all. The city was also plunged into complete radio silence. Meteorologists couldn't even contact the authorities, and local residents were unable to set up any stations. Everyone was in the dark, both literally and figuratively. Meteorologists decided to try and launch several flares. The flares soared into the air towards the heavy dark clouds hanging over the city and disappeared. The clouds were so dense that the flares were completely invisible. At the same time, the weather was perfectly fine. Everything was quiet. And this black silence lasted for about an hour. After that, the Black Day ended as unexpectedly as it began. Even more baffling, those strange clouds left literally no trace. No rain, no dust, nothing. After that event, researchers found out that the Black Day had spread for 125 to 155 miles around. They also learned that the dark band was moving from west to east. After passing through the southern part of the Yamal Peninsula, it headed on for a while and then disappeared completely. Yamal isn't the only place where this phenomenon occurred. In fact, similar eclipses have been happening in different parts of Earth for many years. For example, in New England, on May 19, 1780, people there witnessed an event that was later called New England's Dark Day, but it lasted not one day, but several. A few days before this event, the sky turned yellow, and on May 19th, in broad daylight, it suddenly turned black. Here's what one of the witnesses, Joseph Plum Martin, later told the press. It was very dark. People had to light candles in their houses to carry on with their usual business. The night was as uncommonly dark as the day was. The smell of soot reigned in the air. Nearby rivers were covered with a thin layer of ash. When the real night came, people noticed through the clouds that the moon had turned dark red. Only a couple of days later, people were finally able to see stars through the veil of clouds. And then, everything suddenly returned to normal. No one had any idea what had happened. 22 years later, on June 2, 1802, a schooner named El Dorado sailed across the Pacific Ocean. Suddenly, they were overtaken by complete darkness. There was no storm, and the ocean was completely calm, but the whole sky was covered with black clouds. These clouds dissipated after half an hour and left no trace. And again, 74 years later, one of the dark waves happened in Wisconsin on March 19, 1886. It was 3 p.m., and this time, the wave was very short. It lasted only 5 to 10 minutes. A sudden night fell on the city. Frightened horses were neighing, and terrified people were running around, trying to find a place to hide. When everything calmed down, local newspapers reported that the wave passed from west to east. There was no solar eclipse, no winds or hurricanes, nothing that could cause the darkness over the city. And finally, Once again, it happened on December 2nd, 1904, in Memphis. Or rather, that's what rumors claim, since there's no scientific evidence of this event. It was clear and cold dawn over Bluff City. People were doing their usual Friday morning chores. Then, around 9 in the morning, without any warning, the sun suddenly disappeared from the sky. It took only a minute for the bright sunny day to turn into pitch darkness. People interrupted their work, and children in schools were completely terrified. And just like in previous cases, the weather was perfectly calm. It lasted for about half an hour and then suddenly ended. A little later, following a mysterious eclipse, a ferocious storm hit the city. So, what's going on? All these strange cases can surely be explained scientifically, right? Well, actually, scientists don't have a definite answer. All these events are very similar, but we don't have a single explanation that could cover them all. Let's take a look at some theories. The first thought that comes to mind, it's probably a partial or total eclipse. But no, this is not the case. There were no eclipses on those days, and even if we consider this theory, before any eclipse, the sky darkens gradually. Eclipses themselves only last a couple of minutes, certainly not a few hours or even days. Also, unlike eclipses, these events were local to specific cities. Well, maybe it's some other astronomical event. Some scientists believe that during the event on Yamal, a band of cosmic dust touched Earth, but later they found out that no astronomical bodies approached the planet that day. Alright, any other ideas? Forest fires could be the reason. When a large area of forest is burning at the same time, a column of air can rise to great heights, like 3 to 4 miles. These airflows carry ash and other burnt stuff to different places, and since all these things are so high in the sky, they simply freeze there and turn into something resembling black clouds. That was probably the case for New England. At that time, a wave of forest fires broke out in Canada. They could easily spread through the north of the US. Also, just look at this description. Yellowed sky, the smell of soot, ash on the water. Everything sounds logical, but this theory of fires only works for the event in New England. What about the other cases? Where would you find a forest fire in the middle of the Pacific Ocean, for example? Alright, moving on. Scientists tried to explain the story from Memphis by saying it could be a hurricane, but the black cloud swept through the city before the storm, not during or after it. And it wasn't some kind of typical storm cloud, it was full-fledged night darkness. So what's really going on? Now, meteorologists call this phenomenon a local decrease in the transparency of the atmosphere. Unlike solar eclipses, this darkness is denser. It also covers only a small area. The transparency of the atmosphere is its ability to let through radiation and light. It's basically, how well can I see distant objects? Everything can get dark and blurry, for example, because of the dust in the air, volcanic eruptions, fogs, and so on. So, according to this theory, dark days are just an extreme drop in the transparency of the atmosphere. But it's still strange. If that's the case, shouldn't everything have been covered with thick fog or something like that? Yeah, it was very dark, but when people lit the lamps, the visibility was pretty good. Nothing blocked the view except the black clouds that covered the sun. In other words, this phenomenon is very hard to explain. As far as we know, it happened only 5 to 6 times in the history of humankind. If there were other cases, they weren't documented. This phenomenon is impossible to predict, and no one knows how it worked, as well as where and when it will happen next time. And although there are many hypotheses, none of them can be verified. Maybe if these events happen again in the future, we'll be able to study them better. But unfortunately, at the moment, the dark days remain a mystery. Do you have any theories or ideas on this stuff? If so, write them down in the comments.
Is it possible for a planet to have not one, not two, but many suns? Let's imagine what would happen to us if the sun suddenly decided to break into a bunch of small stars. During the search for Earth-like planets throughout the universe, scientists have discovered that systems of 2 or even 3 stars are not actually that rare. Many of them even have planets in their habitable zones. Almost half of these planets could contain life. Can't wait to ask these guys about the sunsets. Scientists even suggest that our sun wasn't always lonely. It could have had a companion star called Nemesis. They've noticed that mass extinctions on Earth occur every 27 million years. It's like a cycle. So they turned to the stars to find out what the reason might be. And then they assumed that it was a star that left our sun a long time ago, but it still affects us. Nemesis could be located about 1.5 light years from us. It may not sound like a lot, but it's actually almost 9 trillion miles. That's going to be a fun car trip, 50 million years long. Anyway, every time Nemesis passes its orbit, it can affect the Oort cloud. The Oort cloud is an area surrounding our solar system in which comets are formed. Its existence hasn't yet been proven, but scientists are pretty sure about it. So, comets form inside this cloud and then relocate to our solar system. Even being very far away, the second star in the system can have a great influence on it. But what about systems with 4 or even more stars? Is it even possible? Actually, yeah. But the more celestial bodies you add to the system, the more difficult it becomes. The orbits grow unstable. It's going to be as chaotic as can be. In stellar mechanics, it's called the three-body problem. It says that it's very difficult to predict the orbits of bodies in such systems. In most cases, they turn out to be very random and unique. Isaac Newton was the first to have noticed it. He tried to apply his gravitational discoveries to the Earth, the Moon, and the Sun. He found himself with quite a struggle. It wasn't easy to understand how 3 stellar objects orbit so stably around each other. And that's just a planet and a satellite. How about including several stars? I wouldn't envy those who'll have to calculate all this. Oh, right, it's me. Anyway, we know that triple star systems are ridiculously chaotic. But what about systems with more stars? They're very, very rare. In 2021, NASA discovered a star system of as many as 6 stars. That's just crazy. Of course, there are no planets in it, but who knows? Maybe one day we'll find such a system too. In such worlds, the gravity dance is very complex. It takes very specific conditions to hold everything together. It's like walking on a tightrope over an abyss. With all this in mind, let's try to imagine what would happen if the sun suddenly turned into several small stars. Oh, we're going to need a very detailed simulation. No, probably even a dozen simulations to make this thing work, because otherwise, we'd only have a few options. Option 1. We divide the sun into 5 to 10 tiny suns. Now we'll scatter these guys not far from each other. They'll destroy our system in a couple of hours. Yeah. All star systems, including ours, are in constant motion across the universe. So, they'll crash into each other almost immediately. This collision will lead to the creation of a supernova. Our system will turn into a beautiful, colorful nebula. For us, it will happen in just a couple of minutes. We won't even have time to feel anything. And all the planets in the X solar system will immediately turn into sparkling space dust. But it's not the best option for us, right? Let's see if it can go any other way. Option 2. Since they can't be located so close to each other, let's try to set them as far away as possible. And in this case, they'll just leave. Bye-bye. Their gravitational force is too weak to hold everything together. The little suns will simply leave the solar system, flying into space in random directions. After that, the rest of the planets will descend from their orbits, including poor little us, of course. We'll become a so-called rogue planet. At first, we won't even realize that the planet has gone out of orbit, and we won't have time to do anything before it gets incredibly cold. What a sad and poetic end. In general, none of these outcomes sounds very fun. Oh, alright, we still have the last option. Our main problem is that we make each of these little stars the same mass. But just take a look at all these multi-star systems that we've already discovered. You'll see that none of them look like, a bunch of glowing balls together. Instead, there are a couple of large stars there, and the rest, the small ones, are orbiting around them. So how about 2 large stars and 2 small ones? What will the Earth look like then? Well, its orbit will become terribly unstable. We'll shake back and forth. Wouldn't recommend it, honestly. We know what this can lead to because, and that's just crazy, this has already happened to us once. Yes, about 70,000 years ago, a lone star visited our solar system. It was a red dwarf called Scholz. A red dwarf is a very small and cold star, if you count 14,000 degrees Fahrenheit as cold, of course. But it's considered the weakest and coldest type of star, so it probably didn't look that big and bright in the sky. At that time, our ancestors, Homo sapiens, were already there living their lives. And can you imagine? They saw another star in the sky approaching the sun. I wonder what that looked like. And then, Scholz bypassed the sun and flew somewhere further to surf space. You weren't expecting some kind of disaster, were you? If it had happened, you wouldn't have had a chance to watch this video right now. But from this story, we can see what happens to the Earth during such stellar events. At that time, a huge amount of volcanic activity unfolded on our planet. We also got some meteor showers that almost wiped us out. Our ancestors sure had it rough. Something similar will happen on our hypothetical planet with 4 suns, but on a much greater scale. Constant volcanic activity, earthquakes, and tsunamis. Brr. In addition, the length of a day will change, as well as the length of all seasons, and a year as a whole. They won't be stable anymore due to the regular changes in gravitation. In other words, you'll never know when to expect an annual winter or hot summer. And when we are precisely in the middle between 2 stars, there won't be any nights at all. They'll illuminate both parts of our planet, and we'll have to sleep in bright sunlight. And if you think this is a bad thing, keep in mind that we'll also be attacked by much more ultraviolet rays and solar winds because of our 4 suns. Their color will also change. They'll become red dwarfs, looking distinctly orange-scarlet in the sky. We'll also get many more solar eclipses, except instead of the moon, the sun would be eclipsed by another sun. It would probably just get a little darker. To be honest, it's unlikely that anything would survive on Earth after all this. I mean, it is possible, but please run 100 simulations yourself if you want to make sure. But theoretically, we could survive in a simple binary star system. For example, in one that consists of 2 stars close to each other. Each of them would have to be 2 times smaller than our sun. That would be the perfect scenario. And it's quite possible in the future. NASA is currently working on a plan to relocate our descendants to Proxima Centauri b. That's a planet near the closest star system to our sun, Alpha Centauri. And who knows, maybe one day in the future, we'll really move there. Then we'll see what it's like to live with several suns.
Hey, ready to test your knowledge? Of course you are. You'll get 1 point for each correct answer. So, without further ado, the sun is yellow. Do you think this is a myth? Ask someone to draw a picture of the sun, and chances are you'll get a yellow or orange circle in the sky. Surprise! The sun is not really yellow. If you see it somewhere outside the Earth's atmosphere, it'll look white. How come? According to NASA, the sun's temperature is the reason why it's white. The sun consists of all colors mixed together, so it appears to our eyes as white. Then why do you think we see it as yellow or orange from Earth? Colored wavelengths, which are yellow and orange, are longer, and they are the only ones that make it to our eyes. The other short wavelength colors sprawl in the atmosphere, and the sky looks blue to us during the day for the same reason. Meteorites are hot as fire when they land on Earth. What do you think, myth or fact? When people see a fireball around a meteorite, they think it's super hot. Well, this is a myth. Meteorites don't immediately land on Earth. Most of them have been in space for billions of years. Space has a cold environment, just a few degrees above absolute zero cold, you know. But don't meteorites fall into the Earth in flames? How come? The fireball is actually the air in front of the meteorite. It is compressed by the super high speed of the meteorite. The outside catches fire, but that layer is burned off on impact as a result of landing on Earth. As you would probably guess, when they land, the meteorites are lukewarm at most, but not as hot as lava. One side of the moon is permanently in the dark. Do you think this is a myth or a fact? This is a myth. Oh, come on. First the sun and now the moon. Am I living a lie? So, people look at the sky and see only the bright side of the moon. The reality is the Earth shines equally on all sides of the moon as it rotates and orbits the Earth. Half of the moon is in shadow, and half gets sunshine similar to Earth. That's not true. Similar to Earth, it doesn't have a permanent dark side. The logic is simple. The moon orbits Earth, but it also rotates on its own axis. When you think about it, we're always looking at the same side of the moon. Black holes take in everything that comes their way. What is it, myth or fact? Black holes don't have infinite mass and gravitational force, but still, no one really knows for sure what happens to the things pulled into them. Experts do know black holes do not have supergravity, though. Let's imagine this. If there was a black hole as big as the Sun, it wouldn't immediately eat the whole planet. Imagine black holes as vacuum cleaners. It does draw in a cloud of dust near its range, but other specks of dust remain where they are. So even if there was a black hole replacing the Sun, all the planets would continue to orbit similarly. They wouldn't go into the black hole. If the star or something else got into the range of the black hole, only then would its gravity affect the star. When you call someone, the signal bounces off a satellite. Is this a myth or a fact? Yep, it's a myth. Or rather, an urban legend or misconception, you name it. I mean, there are some satellite phones, but we, regular people, don't use those every day. Although your mobile phone works in a much different way. When you call someone, the nearest tower connects you to the other person online. This is why there are tower connections, huge networks of tower-to-tower connections, and hidden cables. The moon has no gravity. Any guesses? Myth or fact? This is an urban legend. Ask any astronaut you know. If you don't know any, just trust me. There is footage proving that the moon has gravity. When I say the moon has gravity, don't think it's similar to the gravity on Earth that makes the apple fall. The moon's gravity is only about 1/6 of Earth's. How does it feel to walk on the surface of the moon? The second man on the moon, Buzz Aldrin, mentioned it's like moving in slow motion and, quote, perhaps not too far from a trampoline, but without the springiness and instability, end quote. The sunset on Mars appears blue. Do you think this is a myth or a fact? This is a fact. Magnificent sunsets. The sky is filled with different shades of yellow. Now imagine this in blue. According to NASA, sunsets on Mars would look bluish, watching them with bare eyes. It's because of dust. Dust particles closer to the sun appear in blue tones. There is something called moonquakes. Does it sound like a myth or a fact? It's a fact. Quakes happen on the moon too, and they're called moonquakes. They have different features, not really similar to the quakes on Earth though. A planet can be hot enough to vaporize rocks. Any guesses? Is this a myth or a fact? This is a fact. The temperature in this universe is indeed very high. There's a planet, the temperature of which is enough to melt and even vaporize rocks. It's 2 times bigger than the Earth. This super-Earth is similar to our planet, but it is way too hot. Experts believe that it possibly has oceans of lava and clouds that rain molten rock. 1 million Earths can fit inside the sun. Do you think this is a myth or a fact? This is a fact. Although the sun is one of more than 100 billion stars in the Milky Way, which is at the heart of our solar system, it can fit 1 million Earths. Yeah, it looks small when we see it from here, but it's only because it's so far away from Earth. All comets have tails, myth or fact? It's true. Some comets simply don't show their tails. They look like someone threw a snowball into space. Space is completely silent. What do you say? Shh, I knew it was too easy. This is a fact. Space doesn't have an atmosphere, so there's no way to hear any sound there. Mercury is the hottest planet. Myth or fact? Mercury is the closest planet to the Sun, so this should be a fact, huh? No, not really. Venus is the hottest planet in our solar system and the second planet from the Sun. But the distance from the Sun isn't what defines the temperature. The heat depends on the atmosphere. So Venus's atmosphere consists mostly of carbon dioxide and some nitrogen. This combination makes the atmosphere very thick. When I say thick, I mean it. Throughout the year, the surface of Venus maintains a temperature of around 860 degrees Fahrenheit. Mercury's surface resembles the temperature of a desert, but is much higher in terms of temperature variations. Venus spins clockwise. What do you say? This is a fact. Venus spins in the opposite direction compared to many other planets. The Sun rises in the west, and its rotation is very slow. Venus needs 225 Earth days to complete its spinning around the Sun. The planet's distance from the Sun affects the duration of one rotation. It's too close to the Sun, and the Sun has a strong, noticeable pull on the planets. Footprints on the Moon can stay there for millions of years. Do you think this is a fact or a myth? Fact checked. The Moon has no atmosphere, so there's no wind blowing, and without the wind, there's no way to erase the footprints without any intervention. So, how many points did you get? Let me know in the comments. Now, did you know that our Sun is actually green? Okay, I'm kidding. But in reality, it's all colors you can imagine at the same time. Wait, what? I know it sounds like a joke, but I'm being serious, can't you tell? In fact, our Sun contains absolutely all the waves of the light spectrum. It's simultaneously red, blue, green, yellow, you name it. Where do you think rainbows come from? When sunlight gets reflected off water droplets in the air, it splits into a bunch of colored waves that we can see individually. And when they're all together, we see a white ray of light. Our eyes are unable to perceive the concept of all colors at the same time, so their combination seems white to us. Wait, you might say, why white? Isn't the Sun yellow? Yep, it's yellow too, but please don't stare at the Sun just to make sure. It appears white when we see it from the International Space Station. This is the Sun's real color as our eyes perceive it. The Sun gets a yellowish hue when its rays get scattered in Earth's atmosphere. Our atmosphere doesn't let the blue rays of the spectrum pass very well, but the red ones? Hey, sure, why not? By the way, that's why the sky seems blue to us. The atmosphere scatters the blue color all over the place. During sunrise and sunset, short blue waves get reflected, but the long red ones reach us perfectly. That's why we see sunsets as pink, orange, or red. But what would happen if the Sun had a different color? To answer this question, let's quickly repeat what we've learned. 1. The Sun has the whole color spectrum in it. 2. Our atmosphere is like blue rays? Nope. Red rays? Anytime. So you probably already guessed what would happen if the Sun was, let's say, red. The whole world would look like it does during sunsets. Not bad, huh? We wouldn't even have to wait for the evening to admire the scarlet sky. Orange water and a bright red moon. Yeah, it would be darker than what we're used to, but still not bad. Oh, by the way, one day, the Sun will actually turn red. When its life comes to an end, it will expand and gradually turn into a red giant before finally burning out. But it's not going to be so much fun for us. So let's hope we won't be around to see that moment. I know I won't. Hey, I've got a party to go to. Okay, now, what if the Sun was green? Well, the truth is, the Sun is green. So here's your dialogue.
Wait, are you kidding me? Didn't you just say that it's white?
Ooh, good job on that, by the way. Well, not exactly, bud. The Sun just looks white, but technically, it has a temperature of around 10,000 degrees Fahrenheit, and the pink wavelength of the Sun's spectrum corresponds to the green-blue hue. But to make sure that the Sun is green, we need to drown out the rest of the visible spectrum. Then our atmosphere will let through a pure green color. And what'll happen then? Well, everything will be green, and everything will also be a bit darker. Well, face it, it's not easy being green. Okay, moving on. Now let's paint the sun blue. Blue stars actually do exist. They're called blue giants. Fortunately, our sun is not one of them. Why fortunately? Well, because if it was a blue giant, it would be a young, beautiful, unimaginably large, and very, very hot star. See, our red is hot, blue is cold logic doesn't apply to stars. The hottest stars are white and blue, and the coldest are yellow and red. Yeah, our sun is actually very cold compared to other stars. Now, take the average temperature in your city, but multiply it by hundreds of thousands. Yeah, we're struggling with global warming here, but global burning? No thanks, blue giants. Anyway, let's imagine that the sun turned blue. How would we see the world? Surprisingly, nothing would change. Remember how I said that the atmosphere scatters blue light? That's why, in this case, everything would remain almost the same. Maybe the sky would get bluer, but we wouldn't see much difference. And finally, the darkest, pun intended, option. What if our sun turned black? Stock up on lamps and candles because there is no more light. People use electricity all over the world 24/7. We also can't see the moon anymore. After all, we can observe it these days only because the sun's rays get reflected off of it. Now, the only thing we still have to illuminate our nights are stars, but they don't help us much. Good thing this scenario is totally unrealistic and there are no black stars, right? Well, yeah, there are no black stars, and still our sun will eventually become completely black one day. And I don't mean a black hole. I'm talking about black dwarfs here. You've probably heard of white dwarfs, maybe even seven dwarfs. When a star like our sun is about to finish its life, it expands and turns into a red giant. And then, gradually losing its upper layers, it turns into white dwarfs. Since they no longer produce fuel, they slowly cool down. All that remains is a small core, living out its life and burning bright. And when the star cools down completely, it turns into a black dwarf. But you've probably never heard of them. Why? Because, surprise, surprise, they don't exist. And no, I was not lying. The thing is, a star needs about 1 quadrillion years to turn into a black dwarf. And our universe is still a baby. It's only about 14 billion years old. So no star has reached this stage yet. Even the most ancient of them still emit a little light. That's why black stars are just a theory. And it's unlikely that we'll ever see such a star at all. But remember the famous saying, the stars that we see at night are already ghosts because their light has reached us only now. Well, that's a myth. They're all still alive. Why am I telling you all this? Well, let's imagine that our sun turned into a black dwarf. The entire solar system would immediately get plunged into absolute darkness. It would also be terribly cold. The moon would leave its orbit and crash into Earth. Wait, no. Let's overlook this moment and assume we're still alive. Fortunately, we wouldn't freeze instantly, as you might think. Earth's core has its own temperature, more than 9,000 degrees. But the temperatures on the surface of the planet would still immediately drop to 32 degrees Fahrenheit. The core would gradually cool down. Every 2 months, its temperature would drop by 2 times. In just 2 months, Earth's surface temperature would be minus 190 degrees, and in a year, it would reach minus 450 degrees. Most plants would disappear pretty quickly, not because of the cold, but because of the lack of photosynthesis. Others would live a little longer thanks to the oxygen still remaining in the atmosphere. And, oddly enough, trees would survive for a very long time. They have a slow metabolism and get sugar from the ground. The upper layer of the oceans would freeze very quickly. Fortunately, this thick crust of ice would insulate deep waters, so the entire ocean wouldn't freeze for some time. Marine creatures would be doing pretty well. They existed long before us and are already used to crazy temperature changes, the lack of oxygen and food, huge pressures, and other joys of deep-sea life. And what about us humans? Well, first of all, we'd start getting sick. Without vitamin D, people would face a huge number of different health problems. Also, our bodies need sunlight to produce melatonin. This melatonin helps us understand when we should go to bed and wake up. If people didn't have this hormone, their bodies would get very confused and wouldn't understand whether they needed to sleep or not. That would mean insomnia for many people. But we would still be able to survive. We'd have two options: to build giant submarines and go down into the depths of the ocean closer to Earth's core, or stay on the surface, living our lives in some location where we'd have sources of geothermal energy. In Iceland, for example. We could also settle near volcanoes. Their heat would be enough to warm us for a long time. Our vision would adapt to the dark, but at some point it would reach its maximum. So we'd need to get used to living in complete darkness. But who knows? Maybe we would adapt to this life too. So, which option would you prefer? Living at the bottom of the ocean in a submarine or on the surface near volcanoes? So, what's going on with all the news about the sun? Some say that the sun is getting angry. Well, what does that mean exactly, and should we be concerned? Frankly, yes, we should be concerned. It's generally not a good thing to get too much sunshine. The ultraviolet component of sunlight is harmful to the skin. That's why humans have adapted a spectrum of skin pigmentation. The more sunlight there is to protect ourselves against, the more pigmentation we need. Big floppy hats and, of course, bottles of high SPF oil-free sunscreen help too, especially for fair-skinned people. But what is planet Earth going to do? First, let's get a good estimate of just how angry the sun is likely to get. The sun usually goes through an active-calm-active cycle every 22 years, with highs and lows occurring every 11 years. Why that happens, no one knows, it just does. There's probably a reason, but scientists haven't figured it out yet. They do know that, with each cycle, the sun reverses its magnetic poles. That in itself is pretty astounding, especially when you consider that Earth hasn't reversed its magnetic poles in the last 600,000 years. Lately, the sun has been extremely calm, the calmest it's been in over 100 years in fact. That's unusual too. The active-calm-active cycle has turned into an active-calm-calm cycle. But that's changing, and it's why we are notifying Brightsiders about what to expect in the coming few years. The terms calm or active or angry refer to the amount of high-energy radiation that the sun gives off. Thankfully, the amount of visible light the sun gives off doesn't change very much. That would be a serious problem. If the sun were to get just 6% dimmer or brighter, the Earth would either freeze or fry. Observing sunspots is the easiest way to measure how active the sun is. The more sunspots that are visible, the more active the sun is. A graph, known as the butterfly diagram, tracks the 11-year period of sunspot activity. The butterfly diagram shows how sunspots disappear regularly from the surface of the sun and reappear regularly in other locations. NASA predicted that the present cycle of solar activity would be calm, like the previous one. But it's starting to look like that is not the case. Presently, we are in solar cycle number 25. That's the 25th 11-year solar cycle since 1755, when record-keeping began. This cycle of solar activity is expected to peak in 2025. The sun has already exceeded the number of sunspots NASA had predicted. So, it doesn't look like this solar cycle is going to be a calm one. It looks like we are going to have some very active sun-blasting radiation on Earth for the next several years. In early February 2022, 40 out of 49 SpaceX communication satellites in orbit above the atmosphere were destroyed by an explosion on the sun. High-speed electromagnetic plasma gas from the sun, known as solar wind, caused the Earth's atmosphere to compress, and Elon Musk's satellites lost their orbital integrity and crashed back into Earth. Sunspots look like dark spots on the sun, but they aren't dark. They're just not as bright as the surface of the sun. To get a better idea, take a lit 25-watt light bulb and hold it in front of a lit 100-watt light bulb. The 25-watt light bulb will appear dark. That's the same way it is with sunspots. Sunspots on the surface of the sun almost always come in pairs. This is because sunspots are magnetic storms in the plasma gas of the sun. One sunspot will be magnetic positive, and the other sunspot will be magnetic negative. Between the two sunspots, which can be many times bigger than the Earth itself, there flows an electric current that carries a fiery arc of ionized gas with it. Solar flares are something else we should be concerned about. They are powerful electromagnetic explosions on the sun associated with sunspots. As the superhot plasma gas on the sun churns and twists, it also twists the magnetic field lines in the sunspots. When these lines snap, A powerful explosion releases X-ray and gamma radiation at the speed of light. Visible gases are also released. Solar flares have a classification system according to how powerful they are. X-class solar flares are the most dangerous. This type of solar flare can cause radio blackouts across Earth and harm satellites, astronauts in orbit, and even passengers on high-altitude airplanes. M-class solar flares cause spectacular aurora at the North and South Pole areas on Earth, while C-class solar flares have almost no effect on Earth. But solar flares are not the biggest explosions on the Sun. CME stands for coronal mass ejection, and these are much more massive than solar flares and more dangerous when they're headed our way. As the name indicates, coronal mass ejections are explosions that originate on the Sun's corona. They hurl millions of tons of hot ionized gases outward from the corona. The word corona is derived from the Latin word for crown, and it's the layer of thin bright gas around the Sun's surface. The corona of the Sun is much hotter than the surface of the Sun. The surface itself is about 10,000 degrees Fahrenheit, but the corona is somewhere between 1 to 2 million degrees. The why and how the corona is so much hotter than the surface of the Sun is another major mystery that scientists have yet to completely work out. A recent theory claims the corona is heated by sound waves and the Sun's nuclear reactions make a lot of noise. Project GONG, which stands for Global Oscillation Networking Group, was set up on Earth to monitor the sound waves on the Sun. Cool, huh? Turns out the Sun is ringing or oscillating like a bell. And we have 5 observation sites across the globe. One in India, Australia, one in the Canary Islands, one in Chile, and one in California that keep a constant watch over the 10 million sound waves moving on and around the Sun. Now that the Sun is entering an active phase, we can expect to see more powerful CMEs heading our way. The gases expelled by the Sun are ionized and stripped of electrons by the intense heat. This causes them to form a proton storm that can travel through space at speeds of around 500 miles per second. These positively charged atomic nuclei will mostly be blocked or deflected by the magnetic field that extends around Earth. Our atmosphere is no help against a proton storm, although the last mile of air above the surface of the Earth stops the harmful X-rays from solar flares. The particle wind from the Sun can only be stopped by Earth's magnetosphere. We can look forward to some spectacular aurora around Earth's magnetic poles, and it's very possible that these aurora will extend down to the mid-latitudes when the Earth is moving through a coronal mass ejection. Currently, the United States has a space probe headed for the solar corona. Because the corona of the Sun extends outward for many millions of miles, the Parker Solar Probe, as it's called, is cruising 3.8 million miles from the surface of our star, or about 1/10 the distance to Mercury. The probe is experiencing temperatures of 2,400 degrees Fahrenheit, but it is also kept at perfect room temperature. A 4.5-inch thick carbon composite heat shield protects the telescopes and magnetometers in the probe that measure the intensity of the solar wind. The 5 antennae that protrude into the coronal gases are made of a niobium alloy, which can withstand the extreme temperatures of the corona. The recent double calm cycle of the Sun is a bit concerning when trying to predict how active the Sun will get this cycle. The sunspots completely disappeared for a long time from the entire surface of the Sun. It is as if the magnetic distortions we usually see on the photosphere of the Sun had collapsed into its interior. Intense magnetism is coming to the surface now and breaking through into the corona. The National Center for Atmospheric Research in Boulder, Colorado, is predicting that this solar cycle, cycle number 25, will be one of the strongest ever. The last solar cycle was very calm, with a sunspot count of only 116. The average is 170. But the prediction for this cycle is between 210 and 260 sunspots, which would be one of the strongest cycles ever. We stand to lose more satellites to a stronger solar wind. We can also expect electric grid overloads as the proton storm peaks in 2025. That means we should expect an interruption to our internet services as positively charged protons get into the wires, run into the transformers, and overload them. On March 12, 1989, a powerful CME hit Earth and created absolute havoc with our power grids. Will we experience anything of this magnitude in the near future? Well, stay sharp, Brightsiders.
Of fire and smoke fly upward, and the rocket launches. The Delta IV Heavy is one of the most powerful rockets people have ever made. 3 massive engines burn tons of fuel, helping the spacecraft gain altitude. The 2 side boosters undock, leaving the common booster core for further ascent. When in orbit, the rocket releases its payload. This is the Parker Solar Probe, the first spacecraft to touch the Sun, and we'll follow its journey step by step. The probe was launched on August 12, 2018, and began its journey toward our star. The Sun is 93 million miles away from Earth. That's 390 times the Earth-Moon distance and 36,000 times the width of the United States from coast to coast. The particles of light that the Sun emits need 8 minutes to travel this distance. For our conventional rockets, that journey would take more than 200 days. But the Parker Solar Probe covered it faster, using gravitational maneuvers. On its way from the Earth to the Sun, the probe circled around our neighbor, Venus. All it had to do was enter the planet's gravitational field and let it attract itself. At this point, our space probe got an extra boost, and it didn't need to waste any fuel. After making one orbit, the space probe's engines changed the trajectory, and the probe left the orbit of Venus. It got enough acceleration to travel to the Sun. And on November 5, 2018, the Parker Solar Probe made its first approach to the Sun. Before touching its surface, the spacecraft had to enter the star's orbit first. To achieve this, it did even more gravitational maneuvers. Only after that did it start circling the Sun, the heaviest object in the solar system with the most powerful gravity. So, it'll give the probe an incredible amount of acceleration with each flyby. The Parker Solar Probe was constantly moving between 2 points. Those were the perihelion and aphelion. Look, here's the Sun, and here's the probe's orbit in the shape of an ellipse. The closest point to the Sun is the perihelion. The Sun was pulling the probe there at an incredible speed. At this point, the probe began to move away from the star. It still had a lot of speed and energy, but it was struggling against the gravitational force of the star. So it gradually slowed down. The point where the probe lost all its acceleration is called aphelion. The star's gravitational force won, and the probe began to move back toward the Sun, picking up speed again. The probe made several circles following a stable orbit, but then its orbit intersected with that of Venus again. Another gravitational maneuver, and after that, the Parker Solar Probe's trajectory shifted slightly, and it gained more speed. The perihelion point of its orbit was now closer to the Sun. The probe made several more circles following this new orbit. Then again, it neared Venus. Another approach to the Sun. Each encounter with Venus corrected the probe's trajectory and gradually reduced its distance from our star. In April 2021, the Parker Solar Probe finally came so close to the Sun that it touched its corona. Although the actual distance between the probe and the Sun was 5.3 million miles, that still counted as a touch. Let's look at the structure of our star by cutting it in half. This is the core of the Sun. It's about a quarter of its width. The core is 150 times as dense as water. Because of the intense pressure and high temperature, nuclear reactions occur there. Hydrogen gets converted into helium, giving off an incredible amount of heat and radiation. The next layer is the radiation zone. This is where the heat is transferred from the core to the next layers. But the photons here don't move in an outward direction. They can be directed anywhere and re-radiated many times. Scientists believe that the average time it takes a photon of light to travel from the core to the next layer of the Sun is about 10,000 to 170,000 years. Then there's the convection zone. This is what's considered to be the surface of the Sun. But it's not a solid surface. It's an ocean of hot plasma. It looks like a bee honeycomb. That's because the heated plasma rises from the lower layers, creating something like mini geysers. And while it's still hot in the middle of those geysers, their edges cool down, creating an amazing pattern on the Sun's surface. The next layers are the Sun's atmosphere. First, the photosphere. This is the layer that gives off light. And that's exactly what you see when you look at the Sun. But careful, don't do that. You need special equipment to look at our star. The photosphere is up to 250 miles thick. This is about the height at which the International Space Station moves above Earth. Then, the chromosphere, or the sphere of color. This layer of the sun's atmosphere gives the star its reddish hue. Solar prominences appear here. Those are powerful emissions of matter leaving the surface of the sun. Their speed can reach 430 miles per second. At some point, they get caught by the star's magnetic field and pulled back. And then there's the corona, a gaseous envelope of the sun. The most powerful ejections take place there. You can see the corona during eclipses, when the moon covers the solar disk. Then you can notice some kind of glow around the star. This is the corona. It extends for millions of miles around the sun. And the Parker Solar Probe touched precisely that area. That's where solar material and radiation are still tied to the star's gravity and don't fly off into space. And all that is beyond that area is the solar wind. It's the material and radiation that managed to escape the sun's gravity and set off into space. The Parker Solar Probe surprised astronomers by providing more information about this boundary. It turns out it's not a perfect circular wall like we used to think. The boundary is broken and uneven. It looks more like a mountain range. These bumpy regions have such a shape because of the uneven flow of plasma from the surface of the sun. The larger and more powerful the flow, the farther the boundary is from the star's surface. But scientists don't know yet what exactly causes this difference. After making the flyby around the sun, the Parker Solar Probe continued its journey and started to move away from the star again. Researchers are expecting another 4 approaches in 2022. In August 2023, the probe will make a flyby around Venus. It'll gain more speed and approach the sun at a record close distance. The next Venus flyby will happen in 2024. And hopefully, the Parker Solar Probe will be able to withstand the high temperatures and radiation so close to the sun. Luckily, scientists have taken care of that. The probe has a solar shield. It's attached to the side of the probe that will face the star. It's about the size of a house window and about 4.5 inches thick. It's made of a special material that can withstand a temperature of about 2,500 degrees Fahrenheit. That's almost 6 times higher than the temperature of a regular kitchen oven. The body of the probe is made of a white material that reflects sunlight. All the scientific equipment is placed right in the center of the shadow of this shield. If the sun's rays hit the unprotected body of the probe at close range, all the equipment will be out of action in just a few tenths of a second. The Parker Solar Probe is equipped with the Electromagnetic Fields Investigation Instrument. This is a system for measuring electric and magnetic fields, radio waves, temperature, and plasma density. The Wide Field Imager for the Parker Solar Probe, or WISPER, is an optical telescope, the one that took those stunning images of the moving plasma in the sun's corona. These streamers are what you see during solar eclipses. The Solar Wind Electrons, Alphas, and Protons investigation measures protons, electrons, and helium ions. It helps scientists study solar winds. It often harms our technology. Unexpected flares on the surface of the sun can cause severe solar winds. They can burn chips and satellites orbiting Earth. Given that we have the ISS, where people work all the time, we need to know more about solar winds and how to protect ourselves from them. While the Parker Solar Probe continues its research, it's already set several world records. It's the closest to the sun human-made object. It's also the speed record holder. During its final approach to the sun, the probe reached a speed of 101 miles per second. That means it could cover the distance from New York to Los Angeles in just 24 seconds. And a trip around Earth would take about 4 minutes. A journey to the moon in such a spacecraft would only take 40 minutes. In 2025, the Parker Solar Probe will make its closest approach to the sun, reaching a speed of about 430,000 miles per hour. But even this speed is only 0.064% of the speed of light.